Okay, so today's class is going to be about advanced memorization. It's going to be about the cutting edge advancements in the field of memorization. So basically, methods that you can use to memorize things that are not are not among the things we have seen already, and they may be things that you are not even going to find in books. For instance, they're very niche. Some of them have more broader applications, but my goal is really to show a very large range of things that you can use to apply to specific things that you're going to encounter throughout your life. And if you're interested in the field, if you want to see what your memory is capable of, because that's was one of the main things that people chose in the interest form when I sent it. It was like most people were interested in seeing what they were capable of doing. So we're going to show a bunch of very cool things that you can do with your memory so that you can explore that if you're interested in that. So a very quick overview. There are two main types of advancements that I want to cover. So um, the first one is trying to memorize new types of things. So let's say we're going to cover things like if you want to memorize binary numbers or cards. They are not things that existed in the ancient world, right? They did not exist when people started to think of memory palaces. But another way of seeing these advancements is seeing advancements about how to memorize more efficiently or more effectively. And these are methods that, such as like the PAO method or three-digit major system. So basically, ways you can encode more information with less space in the memory palace or using fewer images. So there are these two types of advancements. So let's go one by one. Hopefully, it's going to be a short meeting. The goal is really just to give you an overview, just give you a sense of what you're capable of or what people have done so far, give you some ideas of strategies that you can apply in your own studies. So the PAO method, the person action object, is something that I have somewhat talked about with you guys. This is not such a big advancement. This is kind of old. I put in this class because I was going to give a whole lecture on the PAO method. I was going to get you guys like to make your own PAO system, but I felt that maybe you would not be interested in that because this is the type of thing that you do if you're interested in doing it, and if you're not interested in doing it, it's not going to work even if I guide you. And if you're interested in doing it, you need to be willing to do that on your own, because there will be inevitably a large amount of effort that you will need to apply on your own to make this list. So what is the PAO method? Do you guys remember when we were using the major system to memorize numbers? We converted digits 2 by 2. So we picked every 2 digits, converted into an image, and put into the memory palace by forming triples. So the PAO method, we convert the first pair into a person, the second pair into an action, and the third pair of digits into an object. And then we pick this triple and form an image of person, action, object. So it's a person doing an action with an object or on an object. And that will represent 6 digits, because each one of these represent 2 digits. So 3 times 2, 6 digits. So each position of the memory palace, each locus, is going to have this triple, is going to have 6 digits. In this way, this is much better than, let's say, placing one single image in per locus or something like that. Okay, any questions so far about what I said? I'm going to explain more, but like, any questions so far? Okay, but we did that in the class, right? We converted into a person, then we converted into an action, then into an object. Do you guys remember that? Is it okay? So we did convert into a person, action, and object, but converting from digits to images takes time, right? You guys took some time to think of the images. That can be kind of slow. And if you want to be fast in memorization, the idea is to have a pre-made list. So you take every number from 00 to 99 and from 0 to 9, so that you can memorize odd lengths as well, odd lengths of digits. And you convert each one of those into an image by the major system. So you're gonna have this list, this pre-made list, so that when you memorize, let's say you want to memorize 100 digits of pi, you're not gonna every time you're gonna look at a pair of digits and be like, oh, what does this represent the major system? You're gonna have this pre-made list that you have previously memorized and built on your own. And then when you look at the digit, you're going to be like, oh, what is, let's say, what is 1 0? What is the object that refers to 1 0? It's dice, because in my list I remember it was dice. And then you automatically convert to that image, and then you memorize in the memory palace. This is pretty much necessary if you want to do anything like memory competitions, or if you want to be more effective on memorizing numbers. This takes like a week to make and learn. It's not too hard. This is only being taught in this class because this is not a big advancement. It is a big thing in memorization, but it's not a very advanced thing in memorization. It's totally doable. And I know that because we have 110 people, 110 actions, and 110 objects, giving a total of 330 images. It sounds like a lot of elements to learn, but it's not as many as it sounds like, because you're using the major system to help you remember those images. So when you look at 1 0, and in your list, let's say that 1 0, the object associated to 1 0 is dice. When you look at 1 0, you are still going to be helped by the major system, right? You're going to look at 1 0 and be like, oh, it's T or D and S, Z. What is the object in my list? The dice. So you're going to remember it. The major system is going to help you remember your list. You should practice your list enough so that you can remember it quickly, but the major system is always going to be there to help you in case you have some difficulty. Any questions so far? Does everyone understand what I mean? Because now I'm going to show you an example. So here we have a template of a PAO system. I'm going to click here to show to you guys. Let me close this. This is my wallpaper. Okay. So here we have my major system, my PAO system. We have all these. This is like a template. So I built this. This is a 3-digit one, but you have the 2 digits. So each cell here, we have the number from 0 to 9. We have a bunch of options for people. So you can see, you can click in the cell, it opens a bunch. Between the parentheses, we have the names of where I took those from. I took exclusively from like cartoons or movies or shows or things like that. Only fictional characters. I didn't put real people. We have objects here. And between the parentheses of the objects, we have synonyms so that you don't pick the same word for 2 different numbers. Because if you pick 2 synonyms, then you're not going to know which number it refers to. Okay, so we have the 2-digit lists. And the verbs, the actions are in Portuguese, though. But the people and the objects, they are in Portuguese and in English. There are both options. And we have the 3-digit system. A bunch of options up to 9999. This took an insane amount of time. You guys have no idea. It took like months, thousands of hours. I'm not joking when I say thousands of. It was literally thousands of hours. Some of these combinations are extremely hard to find, to the point that I was just Googling like every single phonetic combination. Like, let's say if I was 8, 9, 8. So I would be like, I would be just Googling like wait, 8, 9, 8. So it would be FA, BA, FA. I would first Google, see if something pops up, something similar. Okay, let's change from FA, BA, VA, and then one by one, and that's quite long. It's awful, and it was insane. But here now it's done and it's available online, so you guys can use it as a template if you are interested in creating a PAO list. I have my personal one here, so this is the second tab, so you can see the ones I actually use. So these are all the ones I use here. I do not have an action. I'm going to explain that later. But if you want to build this, you should have an action as well. So this is the 3-digit list. You should focus only on the 2-digit ones, because if you don't have a PAO system, and I don't think any of you have a PAO system, you should build a 2-digit one with an action as well. So you will have actions here. Forget the nothingness one, but focus only on these two. Okay. So you should have an action. You go here, you copy this table, select one from here and one from here, and so on. So you only have 1-digit list of person, actions, and objects, 2-digit lists of people, actions, and objects. Any questions so far? From the current slide. Okay. Does everyone understand what I mean then? The logic of the system? Here we have Tim's Anki template. So this is a guy from the Art of Memory forum, and he has this Anki deck which is basically a template, because when you build a PAO system, you should use Anki to train and practice and learn it. Because this is the type of thing, the system itself is used to memorize numbers, right? But for you to learn and memorize the system, it's just raw repetition. You really just have to repeat, and repeat until you remember it. So we use Anki for that, and that's why it's very helpful to have an Anki template for you to use. If you want to build a PAO system, what I would recommend is basically download this deck, click in this link in the that's available in the slides, download this deck, and then in the deck, you put your own options. So you're going to have basically flashcards in this deck. You're just opening Anki, open the file with Anki. It's going to download 330 flashcards, I think. And in each one of those, you're going to have the positions to add the person, the action, and the object. So you put the name of the person, the name of the action, and the name of the object. And you do that for all 330 images. And then you review them. And that's probably going to take a week for you to learn and be like faster in that. But yeah, any questions about that? If you actually want to do this, talk to me after class or later, because this can be a little bit tricky. I'm just covering like the bigger picture of how to do things. Now, I'm going to move on to a 3-digit major system, which is what I showed you guys, right? That was my system. And the idea is that if you're serious about memorization, and by mind athlete or memory athlete, that's basically people who do memory competitions or memory records or things like that. That's just a common term. If you see either mind athlete or memory athlete, it's usually that's what it's referring to. But mind athletes usually include people who do mental math as well, and other types of cognitive competitions and things like that. So a 3-digit system is better for things more advanced people. So if you want to be someone in memory competitions and you want to use more advanced systems, maybe a 3-digit system is worth it. It does take a lot of time to build it though, so I'm not recommending any of you guys to build a 3-digit system before a 2-digit system. You always build a 2-digit system first. And I'm just showing this because this is more advanced thing. So a 3-digit system is something that is much harder to build, but it makes things very interesting, because now you have like, instead of having 330 images, you have like 1,000 images, because we got to create images from 000 to 999 and 00 to 99 and 0 to 9. So this gives at least 1,110 images. But as I said, we were thinking of using a PAO method. If we were to create a list for people, for actions and objects, we would have 3 times 1,110, which is 3,330 images, which is a lot. What happens though is that we don't have 1,000 actions that we can distinguish in the memory palace, because when you're memorizing, if 2 actions look the same, you're gonna make a mistake in the digit. So you want them to be as different as possible. Does it make sense to you guys? If you see like, if you add like running and walking, to your PAO method, to your PAO system. Maybe it's not going to be as clear to you. Like, what is the difference between running and walking? Well, it's different, but maybe you're going to make a mistake in that. So we want actions that are different. Unfortunately, we don't have 1,000 actions. So usually this system is usually PO. So you have a list of people and a list of objects. So you have 2,220 items, or you have one single list with both people and object mixed. So you have 1,110 items. And you can memorize, instead of memorizing 6 digits per position using 3 images, which is the case of the PAO, you would have 2 images. And that's 33% improvement, which is like useless if you don't do memory competitions. But for people who do memory competitions, that's actually something. That's actually very nice. And it's really what matters when you're memorizing things is the amount of images you have to memorize. It's not really the size of the thing you're memorizing, but if you can encode more things with fewer images, that's better. That means you're being more efficient. So we usually ignore consonants, as I said, and yeah, it takes from 3 to 5 months to learn it, and you gotta keep reviewing it forever, or else you're gonna forget it because it's very intense. Let me think. Okay, I'm gonna show you guys my Anki, which is something I don't usually. I usually don't like to do that, but here's my major system, and I did not test this. So if you see something weird, do not judge me. It is supposed to be weird. So here I'm gonna browse. We have here a bunch. Okay, I opened this one. So this is 747. We have Greg. Who here knows Greg? Okay, that's good. And we have the object is cracker. So we have here all these flashcards, and you can see this is my system. So I needed to add every single one of those. So manually, it's not. Yeah, it did take other thousands and thousands of hours to do this as well. And I needed to Google every single one of those and be like, Greg, Google, download image, paste, and do that for every single one of those 2,222 images. And you can see that some of these, they have more than one image. So this is 3 images. So I downloaded 3 images for this one. So it was not easy. And I'm just ranting at this point, but seriously, it was a lot of work, but it was worth it for my purposes. And yeah, you can see all of these. Let me choose here notes. So we have one single for each number. So yeah, but that's it. You basically have all these entries, and the team deck is very similar, but you have, instead of like thousands of cards, you have like hundreds. So, but you will have the position for the person, you will have the position for the object, and here you have here in the decks. I have here like the objects deck, the people deck, and a review there. So that's pretty much it. Just wanted to show you guys and complain because it was a lot of effort, but it was worth it, I would say. But that's because I'm very interested in the field. And if you're interested in diving into the field and seeing what you can do, definitely build a PAO system. You should definitely do that. But talk to me more about that, and we can discuss how to actually build that. Now let's show something, actually some questions before I move on. Any questions you guys have? Or no? Okay, move on. Okay, good. So let's talk about something that you can actually implement maybe today or this week for something that you may want to memorize. So what I'm going to cover is counting loci. Imagine, let's suppose you want to memorize the periodic table. So you want to memorize the elements. But you want to remember the atomic number of each element, such that if I go to you, and because if you tell me, oh, I know all the elements, if I go to you and I look at you and I'm like, okay, what is the element with atomic number, let's say 67 or 91 or 102, I want you to tell me the atom, and people will expect that. And What happens is that if you memorize using the memory palace method and just put the elements there, you don't necessarily you don't necessarily have the capacity to recall given that trigger. Like if I look at you like, what is the one at position 71? You're gonna be like, I don't know. I gotta like go through my memory palace, I guess, and just count, and that's awful. You know, you're gonna count 1, 2, 3, 4, 5, up to 80, whatever. So that's going to be very hard. Instead of doing that, what we do is to plan that beforehand. So you go, and before you memorize, when you're building the memory palace, you pick a memory palace that has, let's say, 10 rooms. And in each room of the memory palace, you're going to put 5 loci, 5 positions, so that each palace is going to have 50 atoms. You're going to put 1 atom, 1 element per locus. So you're going to have 50 elements per memory palace, 5 elements per room. So if I ask you, what is the element of atomic number 67? The periodic table, it is ordered by atomic number. So you memorize the atoms by atomic number in increasing order. And then you close your eyes, go to the memory palace, and you ask yourself, okay, 67, that's greater than 50, so I can skip the first memory palace. Because there are over 100 atoms, you're going to need to have 3 memory palaces to do this idea. So you're going to skip the first memory palace and go to the second one. Okay, we have 17 elements left. Well, each room has 5 elements. So you're going to skip 3 rooms. So you skip 15 elements. And now we have 2 remaining elements. So you skip 3 rooms in the second memory palace, and you enter the 4th room. Okay, you enter the 4th room, and you have 2, it's the second element. Okay, there's 2 remaining there. So you skip the first locus, and you go to the second one. That's the element you're looking for. Does everyone understand the logic? You got to do the mental math when you're going through the memory palace. But that's why you need to plan it beforehand. And that's why we choose numbers that make sense. We choose 5 and 10 because it's easier to make mental math with 5 and 10 rather than 7 and 13 rooms. That would be awful. So we do like 5, 10, easy numbers to do mental math with. So this way you can memorize like a very long list of things, and if anybody asks you for the position, you're gonna know. And you can do that the opposite way as well. So if you are in the memory palace and someone is like, okay, what is the atomic number of such and such atom? So you go to that atom and you're like, okay, this is the position of the atom, because it's usually not that hard for you to find the image in the memory palace if you have the image. So you're like, where did I see that image? Oh, it's in the sink, in the kitchen sink. So you go there, you see, okay, what is the number of this room in this memory palace? So you count. Oh, this is the 4th room. You leave the room, you're like, okay, this is the 4th room. But what is the number of this memory palace? Then you're going to be like, oh, it's the 3rd. So just keep multiplying the other way. So 50 times, and then you keep adding up until you find the atomic number. So you do the opposite direction of this logic. Does everyone understand the idea behind this strategy? Now, another thing you could do, and this is for numbers, is like, imagine you memorize 1,000 digits of pi. And you're like, someone goes to you and is like, what is the digit at position 801st? Well, we have a difference here from the last case, because we are not going to memorize 1 digit per position in the memory palace, or else you would have a ton of positions. And that would be awful. What we do, though, is that we use the the PAO method, right? So we have 6 digits per locus. We have a person doing an action with an object in every single position, in every locus. So what we are going to do is that, again, we are going to create, we're going to have 6 digits per locus, 5 loci per room, which gives 30 digits per room. And we are going to have 10 rooms per we're gonna have 10 rooms per memory palace. MP is memory palace. So we're gonna have 300 digits per memory palace. Now the calculations, they change a little. Instead of subtracting 50 positions, we're gonna subtract 300. So is everyone following the logic here of how this should be done? So we have 800 first. I want the digit at 800 first. Okay, so, well, I gotta skip a certain multiple of 300, which is like the amount of memory palace I have. So that would be, what is the closest, the highest multiple of 300 I can skip without overpassing 800 first? Well, 600. So I skip the first two. And now I have 201 left. Now I gotta skip what? I skipped the first two memory palaces. I entered the third memory palace. And now I'm going to skip rooms. And each room has 30 digits. So I gotta skip a multiple of 30, the highest multiple of 30 I can skip. So then I skip 180. And that gives me 21 left. And then I go enter the next room. Now I gotta skip a multiple of 6 because each locus has 6 digits. Then I skip wait, what? No, okay. So I skip a multiple of 6, and then I have at the end I have 3 digits left. And now when I am in that position, in that spot, I'm looking for the third digit inside that locus that I'm looking at. I know that the person in the locus encodes 2 digits, and the action is going to encode other 2 digits. If I skip the person, I get rid of 2 digits. So I was looking for the third one, get rid of the person. Now I have 1 digit that I'm looking for is going to be the first digit of the action. This is hard and confusing. I know it's a lot of mental math and requires some preparation. But I believe that if you get this done, it can be very worth it. If you are thinking of memorizing a lot of numbers, I would definitely do that if I could do it again. If I was going to memorize something for long term, because all the digits I memorized, like Euler's number and the golden ratio, they were for a record. But if I was memorizing them for like long term, like if I was to memorize 1,000 digits of pi, I would probably use this method so that if someone asked me, what is the digit at position such and such, I would tell them. That would be very cool. But one thing that you can use to help you is landmarks. And what are landmarks? They're basically images that refer to the position that you are in the memory palace. So here you can use, for you not to get lost in the memory palace, you have a memory palace with 10 rooms. I want to go to the 7th room. How do I know where the 7th room is? I gotta count 1, 2, 3, 4, 5, 6, 7. It's kind of slow. What you can do, you place an image that refers to the number 7 or the number of the room's number in front of the room. So 7, let's say your image for 7 is a hawk. So you just imagine a hawk in front of the room 7. And you do that for every single room. That's called a landmark. You can do that differently as well. Landmarks are used in very different ways in memorization. So you can do like every 50 digits, I'm going to put the number of digits that lie behind it. So let's say you put, after 50 digits, you're going to put an image that refers to the number 50 using the major system. After 100 digits, you're going to place an image that refers to the number 100, and so on. And what happens is that when you're going to look for the digit 110, you're going to be like, okay, what is the image? What is the landmark that refers to the number 100? Then, in my case, it is a character called Tsui Asui. So I would be like, okay, where do I find her? Then I would automatically go and think, oh, she's there. I would go to that position, and then if I'm looking for the digit 110, I just have to count the other 10. So landmarks can be used in very different ways, but that's just an idea. So throughout this class, I'm just throwing a bunch of strategies that can be implemented so that if someday you're like, I want to go into this, or I want to memorize this specific thing, you probably can find some strategy here that could help you possibly. Any questions so far? That was a lot of math for memorization. So can I move on? Okay. Now I'm going to talk about something that I find very fun, which is memory teleporters, which has a very cool name. Basically, imagine instead of having images to represent items, instead of having images to memorize things, you have images to memorize other memory palaces, to refer to other memory palaces. So you enter a memory palace, instead of seeing an image that refers to apple, an orange, or whatever you have to memorize, it's going to refer to another palace. So imagine you have a very long list of things you memorize and you use multiple memory palaces. And the second memory palace is John's house. So what you can do is imagine John is your friend and you have visited their house, so you use it as the second memory palace. You can put John at the end of your first memory palace. So when you finish your first memory palace, you're going to see John and you're going to be like, oh, I gotta go to John's house now. So you go in your imagination, go to John's house, and now you're in the second memory palace. So you can connect as many memory palaces as you want and create a very long sequence of memory palaces. So that's called memory teleporters. What do you guys think? That's sweet, right? That's an intelligent idea. You just put an image of another memory palace, and now oh my god, you're there. So that's very cool. To make this even cooler, we have massive memory palaces, or Gavino's memory palaces. And what are these? So imagine you want to memorize a tree, a very long tree, like a tree structure. Let's say it's a family tree, and you want to memorize a ton of information about every single person in the royal family, and you want to memorize every single detail. Imagine a historian. I want to know everything about every single one of those. What you could do is to have a memory palace for every single one of those people. And how could we do that? How could we connect them? We can use memory teleporters. So look, you have this tree of the royal family. So each member of the royal family in the present and the past is going to have their own memory palace. And what we're going to do is that we're going to add, for the upper layers, we're going to add memory teleporters to the layers below it. So to the children, to the memory palaces referring to the children. So basically, we get this weird structure of you enter the palace, you see a lot of information, and then at the end, you have this teleporter that takes you down. And then you go one layer down, and now you're in the children. You're in the layer respective to the children. And then you keep going down, and every time you reach an end of a memory palace, you see the teleporters to the places you gotta go. And that's very cool, isn't it? You just keep going. You can create this complex structure. Instead of having a linear structure of a memory palace, you can just build this very weird connection. So this idea is usually called massive memory palaces, or Gavino's memory palaces. And the initial idea was that if you had a ton of very small and tiny memory palaces, you could group them more easily by using a massive memory palace and using memory teleporters to remind you of the smaller ones. So you have a big memory palace containing only memory teleporters, and they remind you of the tiny ones. So you have them ordered in an easy way. But these are other applications you can have as well. Okay, any questions about this? Do you guys understand what I mean? I'm not sure if it's followable, let's say. But yeah, that's a lot of info. I really hope to make this class like short, so I'll move on. So here we have binary numbers. So what are binary numbers? What are binary numbers? Does everyone know what a binary number is? Sure, Sean. 0 or 1. Yeah, so there are numbers made of zeros or ones. And imagine you're for some reason, whatever it is, you want to memorize a ton of 0 and 1s, like 0, 0, 1, 1, 1, 0, 1, 0, 1, 1, 1, 1, 0, 0. You just want to memorize that weird sequence for no reason. So that's what mind athletes did. They were like, well, let's add a modality here in the memory computation. What is it going to be? Well, it's going to be binary numbers. We're going to memorize just this sequence of 5,000 binary digits. For why? Because why not? So here it is. How do we do that? We convert binary digits into decimal digits, and we chunk them 2 by 2, form the images using the PAO method, and memorize that in the memory palace. So basically, every single digit of the PAO method has 2 digits, right? Every image has 2 digits in the PAO method. Each digit refers to 3 digits in binary. So you're memorizing 6 digits, 6 binary digits per image, per person, per action, per object. So you have 6 per each, so you have 18 binary digits in every locus. So see, the information is very condensed, right? You can condense a lot of binary digits. So this is much better than, like, if I had not told you guys, memorize the sequence of binary digits. With the content that I showed you in the previous lectures, you would probably be like, how would you do? You would probably, I guess you would convert, well, 0 is going to be the image for 0, and 1 is going to be the image for 1, and I'm going to place that in the memory palace and make this huge sequence of just repeating images of 0s and 1s in your memory system, right? Isn't that what you guys would do, or would you guys think of something else? Any other ideas you guys would think of? Because it is hard to think of this initially. So one of the goals of this class is really to present this idea that we don't necessarily need to look at info and be like, well, I want to memorize this. What should I do? Just put it in the memory palace. You can create systems to convert that and be like an intermediate layer to process the information before you place that in the memory palace. And that's very cool. Like, you can create very complex systems, which is what I'm going to show before. Any questions? Any questions about this? Okay. So we can create very complex systems like the one I'm going to show right now. It's not as complex, but this is about card memorization. So you have memorization of a deck of cards is another modality of memory competitions. So you're given a deck of cards. It's shuffled, obviously, and you need to memorize the sequence of cards. You could think, well, I could just create an image for every single card on the spot, but that's slow. That's extremely slow. So what do? We create images for each card. But how am I going to remember the image for each card? It's hard for you to remember an image for each card unless you have a system for you that tells you how you should read the card and convert it to an image. So what we do is basically, this cute system here is just an example of what we call one card system. It basically converts every single card into an image, So here, what we do, we have a card. A card, for those who don't know, is made of a rank and a suit. So you have 5 of spades, 7 of clubs, and so on. And the picture cards, they're also ranks. Okay, so the rank is from A to 10, and we have jacks, queen, and king. So the jacks is J, queen Q, and king is K. So we have 13 ranks and 4 suits. What do? We basically convert every single rank to a number. The number ranks, they're very easy to convert. They're numbers. The picture cards they're a little bit weirder. We convert like jack is 6, queen is 7, king is 8. That's just an example. So we attribute those numbers. And the suits, we can do spades 0, hearts 1, diamonds 2, clubs 3. The numbers, the specific numbers for these two, they don't matter as much. The only thing that matters is that these numbers cannot intersect with these numbers. They cannot share any number. And why is that? Because if you notice here, we have 10 ranks, 10 number ranks, and 3 ranks that are not, they are picture cards. So if I wanted to convert a card into a digit, I could place the digit of the rank next to the digit of the suit, and it would form a 2-digit number, and convert that into an image using the PO system, right? However, I still have 3 picture cards. And we only have 10 digits. So how can I differentiate 6 of spades, in the case of 60, how do I differentiate 6 of spades from jacks of spades? How could I know the difference? Right? Any ideas of how I could do it? If you didn't read the rest of the slide, like how could I differentiate that? Like the logic behind that. So I have 60. If I were to read, well, it should be, if I look here, conversion, the first digit is 6. It's the rank 6. 0, if I analyze the suit, it's the spades. It should be 6. It should be 6 of spades. But what if I want to memorize jack of spades? I could do an inversion. So every time I see a picture card, I put the suit first before the rank number. So I would have 0, 6. And because I'm placing the suits after, normally, I'm placing the suits after, the second digit should not be above 3. If the second digit is above 3, I know that that number refers to a picture card. Because if I have 0, 6, when I look at the second digit, I was looking for a suit, but 6 cannot be a suit because the suits range from 0 to 3, so that must be a picture card. 6 refers to jack, and the first digit must be the suit, actually. 0 is the spades. So now we know 0, 6 is jack of spades. So we do this inversion. This is a little bit tricky. Do you guys follow? Can you guys understand the logic here? So things don't intersect. That's the only reason why this set can intersect with this set. So those are some examples. The only rules you gotta follow is basically the number of ranks come before the suits. So if you have a number card, the number of the rank comes before the number of the suit. But if it's a picture card, the suit comes before the number of the picture card. So that forms the 2-digit number. Okay, these are some examples if you're interested. This is a very big modality in memory competitions. But yeah, any questions so far? Okay. So now we're moving to the last topic, which is the shadow system. So imagine, when I say card memorization is a very big thing in memory competitions, I mean it, because there are people who, like, the biggest and most complex systems, they are made for this modality. So we have 52 cards in a deck. If I want to memorize, instead of memorizing 1 card per image, what if I memorize 2 cards per image? That would be much more effective. Because in the previous system, I had to memorize 52 images in the memory palace to memorize a deck of cards, because every single card refers to has its own image. But here, if I put 2 by 2, I group 2 by 2, I'm gonna need to memorize fewer images. So that makes my life easier. It makes memorization faster. So a 2-card system theoretically would be better. So here we have how many pairs of cards? We have how many combinations of pairs of cards? We have 52 times 52, 2,704. There are systems that to do that, to memorize pair by pair. What they do is that the mind athlete, what they do is they create 1 image in their system for every single possible pair of cards. So they have 2,704 images that they put, let's say, on Anki, and review them like thousands of times until they memorize all of them, and now they can use them to memorize decks of cards. That's very hard, right? That takes a lot of time, and that's one of the systems that does that is the bend system, and it is, yeah, it's a very complex system, but it's simple, but it's tough to learn. Because it's so tough, people came up with another system that has just half the number of images, which is like just half, which is 1,352 images, which is called the shadow system. Okay, any questions so far? I'm gonna go. Any questions so far? Okay, so here's the idea behind the shadow system. we're going to use just half the number of images. But at the same time, I want to recall exactly what that image refers to. I want to know exactly which pair that image refers to. I do not want to look at the pair of images. Sorry, I do not want to look at the image and be like, I do not know which pair this refers to. Because obviously, if I have two sets and I'm creating a system that converts from one to the other and vice versa, if one set has half as many items as the other, how can I create a connection that is bijective, as we see in mathematics? Like, how do I know? How it's not possible. They have different numbers of elements. So we gotta be smart about that. Any ideas about this? Like, how can you memorize using half as many combinations as you have? How can you memorize them in the memory palace? How can you place them in the memory palace in such a way that when you look at them, you know, oh, this image refers to that pair, not the other pair? Do you guys have any idea of how this could be done? If you have any questions, ask me. If you didn't understand what I mean. Any suggestion? And that's the only reason why I'm showing this system. This system is very complex. I don't expect anyone to want to create one. I just want to show the strategy, the idea behind it, because it's very, very, very smart. Does anyone have any suggestion of how we could do that? So this is the trick is the last bit of this of content of this class. So the idea is something called variable image stacking. So what we do is that every image of the system refers to a pair that has such that the first suit is red and the other is black. So the image for this pair would be the same image for this pair. What we want to differentiate is whether the image refers to the pair that starts with red or the pair that starts with black. So for that, we use variable image stacking. What we do is that when we are memorizing using the system, if the pair of cards, the first card of the pair has a black suit, we place the image for that pair in the current position in the memory palace, in the current locus. If the first suit of the pair is red, we place it in this locus and move to the next one. So insofar as the first suit of the current pair is black, I stay there. I only move to the next one if the first suit of the pair is red. Then it's like a stop sign, like place it and go. Put it here and go. When you try to recall the cards and you look at the images in the memory palace, you know that every single image, from the first one to the second to last one, they all refer to pairs such that the first card of the pair has a black suit. So you can, using the shadow system, recall exactly which pair of cards it is. Only the last one has a pair of cards such that the first card has a red suit. Do you guys follow the logic here? Do you guys get the trick? So this is very new. For instance, one person who uses this system is Alex Mullen. He used the shadow system. His current best time, I think, is 12 seconds, 12.25 seconds. That means, like, imagine going that fast through cards. It is very hard, requires a lot of practice, and the system is quite complex. So you need to get so familiar with the system that it becomes like second nature. But yeah, basically, this is just a short text. The goal of this lecture today was really just to show a bunch of methods, like just a ton of methods that can be used to memorize all sorts of things, like very different types of things. And the next lectures of this course are not going to be about memorization. They're going to be exclusively about learning. So about understanding. let me think. They're going to be about higher levels of learning. So we're going to go back to what I talked about in the first lecture, which is like the idea that we have levels of cognitive processes. So far we only talked about memorization. We didn't talk about how do you understand content? How do I apply content? How do I apply material? Like if I want to be good at math, what should I do? I'm going to talk about things like expertise or test taking. So how do you become an expert in, let's say, it can be sports, or it can be math, or it can be whatever. The field of expertise, it has certain patterns that repeat across many different dimensions. So whatever you want to be an expert in, the process is usually very similar. So if you want to be an expert at a certain skill, developing that skill usually follows the same pattern. So I'm going to be covering all of that. I'm going to be covering things more in the sense of how you can learn things, not just memorize things. So this was pretty much the end of the art of memory. And before I finish, any questions you guys have? Okay. Do you guys have any requests of things you would like to learn about learning? Because I haven't made the slides for understanding and applying and test taking and all of that yet. If you guys have any requests of things that, let's say, oh, I want to learn how to prepare, how to avoid, let's say, careless mistakes in exams, or I want to know how I can, let's say, read an entire textbook in the fastest way possible. Like how can I minimize my time? Let's say, how can I do mind maps, or how can I learn how to be good at applying formulas? How can I improve applying formulas? I would be interested in that. You tell me. Okay, tell me after class or any other day. Just email me, message me, because you guys can guide the content of the class. Second midterm is today. I've sent the link to the midterm to the email, so you guys have access to it. It's basically just quick questions, completion based. Just send it to me, and that's fine. And that's it. If you have any question, just let me know. And yeah, thank you. Have a good one.